So I'm going to pass out the multiple choice sections. Let me orient you to them before I give them to you. Everybody take a look here. You're going to receive the answer sheet. This is familiar to you. You're going to fill in questions 1 through 28 only. The multiple choice section is a 55-minute no calculator section. So you're going to put away your calculator, give yourself 55 minutes to do the problem. You're going to do it with no help from anybody or any internet or any other thing. And then you're going to put the answers here. You can go ahead and tear the answer sheet off. That makes a whole lot of sense. And you can write on the packet as much as you want. You can have some spare blank paper if you need to do that. There's 55 minutes anytime between now and then you'll turn it in on Monday when you come to class. Yes?
There was like other homework assignments for this weekend. Are we also doing those?
That's this.
Oh, that's all. There.
Yeah.
Because
Yeah, the MC section 1 that's listed there. This one.
I thought you said number 5.
That was last time.
That was last time.
There was an MC number 5. Don't worry about that. I didn't get to you.
So that's the only thing you're on. Or no?
Let's look.
Edmodo says
Oh, I see. MC section 1. Never mind.
MC section 1 received in class on Thursday. See, there you go. So we're good. But you do have an AP problem for tonight. It's a motion problem.
Yeah.
Okay. So is everybody clear on the directions? How about MC number 5? No MC number 5. So, how many minutes? It says, right? And calculator or not? No. Help? No.
Mr. Cagle.
Uh-huh.
On this, it says x equals c is a critical point for f of x. Well, what would that be if it wouldn't be critical? How would it be critical point for f of x if for the point of inflection if you're looking at f double prime? Changing signs.
Let me look at that. I may have made a mistake on that. And remember my 2 words of advice, right? Answer how many questions? All of them. And don't get stalled out. If there's a question that is bothering you, move on with your life, because question number 28 is worth just as much as question number 1. And remember also, the curve is very generous, so don't panic as you go through the thing. But the goal here at this stage of the game is a learning goal. So if there's something that you don't know, then mark it in your mind to ask about later. Okay, let's figure out who's not here, and then we'll move on to our next thing. I'm going to pause this for just a moment. We're going to take a look at last night's homework problem, which was 2011 number 4.
Well, I kind of did. I just didn't get the first part because I didn't know how to find FOT.
There it is.
No, I know, but I mean, I don't know how to. Is it? I don't know. It was. Oh, because.
May I guess? May I guess that T's and X's messed you up?
Maybe. I don't know.
Okay,
I don't know.
let's find out. We'll walk through this, guys. There are 2 goals for today. One goal is to remind you about how to deal with integral functions. Now, this is not exactly an integral function. It's 2x plus an integral function. But it's going to illustrate all the principles that we need. Second of all, I want to come back to the idea that we've talked about many times, and that is, when in doubt, throw a theorem at a problem. That's what we're going to do when we throw theorems at problems. And the third thing is I want to review the mean value theorem, because the mean value theorem is extraordinarily important in analysis, so you need it. And it's tested every year, so you need it. And there it is. All right. So we have a continuous function defined on the interval -4 to 3. The graph of f consists of 2 quarter circles and 1 line segment. Just to keep my head straight, I'm going to mark those quarter circles in different colors. I know you want to have different colors on the test, but visually we want to do it. Now let g of x equal this function right here, which looks a little scary to me, but I'm going to put aside my fear and move on. Find g of negative 3. Okay. G of negative 3 is, according to the definition, 2 times negative 3 plus the integral from 0 to negative 3 of f of t dt. So I needed to do a little substitution. Then I also needed to observe that the integral limits here are inverted. That is, the top limit is less than the bottom limit. So I need to rewrite this as negative 6 minus the integral from negative 3 to 0 of f of t dt, so that I can integrate from here to here safely. Now, integrals give me net signed area. And the area of this guy right here is going to be 1/4 of pi r squared. So I'm going to go ahead and write that area directly into my figure there, just in case I need it. And I do. So I'm going to have negative 6 minus 9/4 of pi as g of negative 3. Okay. How about g prime of x? Now, if g of x were just the integral right here, that would be easy, right? But it's not. So I'm scared, so I quit. No, I don't. I use my derivative rules. G prime of x will be the derivative of g. And just taking a moment to write it like this helps keep me from doing silly things. Because now I can use my sum rule on my function and go term at a time so that I get 2 plus the derivative of my happy integral function, which is f of x, using the fundamental theorem of calculus. And they want me to evaluate g prime of negative 3. So g prime of negative 3, substitution, is 2 plus f of negative 3. Now we come to your question. How do I find values of f?
Oh no, I understood that part. It was just, I accidentally did the wrong integral.
Gotcha. So that gives me 2 plus 0, or 2. And so that's part A. My part A is messy because I wrote on the problem sheet, because that's all I had here for you guys to see. Yours, of course, looks much nicer because it's on a clean sheet of paper, right? Okay. Yep. I apologize for modeling bad habits for you, but because of the limitations of the smartboard, I'm kind of stuck. Okay. Determine the x-coordinate of the point at which g has an absolute minimum. Justify your answer. All right. I look at this. I look at the question. I look at the question again. And I do not try to psych out the question by saying, oh, look, f has a minimum there, so that must be g's minimum. No, wrong. Instead, I appeal to a theorem. I have some theorems about absolute, oh, did I read that as minimum? They want maximum. I have some theorems about maximums. I have 2 theorems about maximums. First of all, the absolute maximum can only occur at critical points or endpoints. And second of all, the absolute maximum will occur if f prime, g prime, goes from being positive over an entire interval to being negative over an entire interval. That's my argument from the sign of g prime. So let me find out about critical points and the sign of g prime. First of all, let's have g prime equals 0 to find those critical points. That would be 2 plus f of x is equal to 0. That's an interesting question. How do I find out where 2 plus f of x is equal to 0? Okay. Can anybody write this equation so it's a little friendlier?
F of x equals negative 2.
Aha! F of x equals negative 2. There you go. And if I have to solve f of x equals negative 2 on a graph, then that's really the same as finding a point of intersection. That's right. It's finding an intersection point. Here comes y equals negative 2. Here comes f of x. And these two right here will intersect right at that point. It's like doing it on the calculator, except without a calculator. Okay? But now the question is, what's this point? And I could guess, and if I guess, it looks like it's about 2.5, but I'm not really sure. I need, yes, that's right, we've got a line. So let's get that line equation really fast. I've got an intercept at 3, and I've got a slope that is over 3 and down 6. So this equation is y equals negative 2x plus 3. And if I set that equal to 2, then I get x is equal to 5 over 2, which is 2.5. So that's my single critical point. Since I have a single critical point, maybe an argument from the sign of g prime is for the best. And if I take a look at g prime is 2 plus f of x. Notice that 2 plus f of x is going to be positive wherever f of x is bigger than negative 2. And it is going to be negative whenever f of x dips below negative 2. So because of that, I can immediately write my magic language. I can say that g of 5/2 is the absolute max because g prime is greater than 0 for x less than 5/2, and g prime is less than 0 for x greater than 5/2. This question was a challenging question, not because it required any skill that we didn't know, but because it required us to not be afraid of a question that looked weird. You see it? The fundamental problem-solving skill that was required here was not anything brilliant, it was courage to simply do what we knew to do with the theories that we had. Number C. Any questions about this? Number C. Find all values on the interval blah, 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 for which the graph of G has a point of inflection. Give a reason for your answer. Tell me 3 different ways to find points of inflection for G.
Double branching sign.
Or f goes through its tangent.
Look external.
Yep.
That's it.
Or the whole tangent.
I'm gonna use
The whole time.
I don't understand how the graph of f and g is different. I just don't understand.
Aha. Good. All right. So she doesn't understand how the graph of f and g are different. How many of you are kind of in the same boat? You look at the graph of, you look at questions about g, and you kind of look at the graph about f, and you're like, are these the same or different or what? How many of you are having that visualization problem? Okay? That's very common. And here's the way that I keep my head straight on those questions. And that is by starting off life, when I get this g right here, what I immediately do is I compute for myself, using the fundamental theorem, both g prime and also what is g double prime? F prime of x. And this helps keep my head straight because now I take the question, g has a point of inflection, and I apply my theorem to say I want f prime to change signs, or I want 2 plus f of x to be at a max or min. And now I can turn my question about g into a question about f, and I have f. So that 2-step process helps to dispel the illusion that wants me to take f and g and kind of put them together. Does that make sense? And it's the use of the theorem to disentangle g from f that makes the question doable. So now I really like the idea of finding the max and min for g prime, and I observe that on the interval -4 to -3, not including -4 or -3, that f only has one extreme value, and therefore 2 plus f only has one extreme value also, and that's at 0. And so I would say for part C that g of x has a point of inflection, standard mathematical abbreviation, POI, at x equals 0, because g prime equals f plus 2 has a local max. And that's it. You could also say because g double prime equals f prime changes signs.
Yeah.
But this is preferable because you're looking at f.
Yeah, the programs can sign we can still do the
Mhm.
last step increasing.
Yep, very good.
How would you say it goes through the tangent line on this equation?
You could. There's no way to really look at this graph right here because the values of g are going to be found by finding areas, right? And there's no way to effectively look at the area values here and argue that g is through its tangent lines. That method is a true statement, but it's not computed. Does that help, Heidi?
Yes.
Good. Notice also that this is almost a graph of f of g prime question, right? That f here is almost g prime. It's not quite because it's g prime moved down by 2. D. D is where I wanted to talk about the mean value theorem. And so today we're going to do a little bit of review. And we have plenty of time for it, which I like. Okay. The mean value theorem is a theorem that connects an average rate of change to an instantaneous rate of change. That's its purpose. And our setup for the mean value theorem is that we have a function f of x and we have an interval a to b, like so. And on this interval we have two conditions. And if both conditions are met, then of course the conclusion is guaranteed. Our first condition is a condition of continuity. If f of x is continuous on the closed interval a to b. So I have to have continuity on the closed interval. Notice that all of my theorems that require continuity on a closed interval. The extreme value does, the intermediate value does, and the mean value does. And that's actually not accidental because the extreme value theorem is used to prove the mean value theorem. So any condition for extreme has to be a condition for mean. The second condition is if f of x is differentiable. On the open interval a to b. Give me a synonym for differentiable. Not quite. F prime of x doesn't have to be 0. It just has to have a value. That's right. So another way of saying it is that f prime of x exists on a to b. Nothing about 0, nothing about changing signs. Notice that that f prime does not have to be continuous. It just has to exist. Okay? Notice also that I do not require that the derivative exists at the endpoints. So it is possible, for example, for a function to satisfy these conditions and have some point of non-differentiability on the endpoints. If it doesn't, that's okay too. But I don't require that it be differentiable on the endpoints. So that's my one little escape clause. All right. If these two conditions are met, then I have a guarantee. And the guarantee is that the average rate of change of the function over this interval has to equal the instantaneous rate of change somewhere. And the average rate of change is the slope of the line that connects these 2 points. Remember that average rate of change, that a rate of change is a slope. And so the average over A to B is going to be the slope of the line that connects the 2 points at A and B. Well, how do I construct that? If these two conditions are met, then there is a C somewhere in AB such that, and now here we go, my average rate of change is going to be the slope between those 2 points, which is f of b minus f of a over b minus a. Everybody sees how this computes a slope? And everybody sees how it computes a slope over the interval a to b. So this is a bona fide average rate of change. And they are connected in this way that the average rate of change equals the instantaneous rate of change at least 1 point. And the instantaneous rate of change is going to be the slope of a tangent line. And these two, what about them geometrically says that they have the same slope? They're parallel. Tangent line is parallel to secant line, is another way to say that in English. Tangent line is parallel to secant line. And in this particular case, I happen to have 2 different values of C. Is that a problem? No. I guaranteed that there was a C. Did I deliver? Yes. Did I guarantee there was only 1 C? No. There might be 2, there might be 10, there might be an accountably infinite number of C's. A whole lot of C's. Actually, there might be an uncountably infinite number if f is a constant. Okay, so this is the 2 conditions and the conclusion, and you just have to know the strict legal language. Yes?
How would that graph that?
Hmm?
Yeah, how's that happen?
I just made up a name.
Oh, okay, you just explained it there.
Yep. You may have noticed all year, if I have to do a random F, I do this graph.
Yes. Is it easiest to work with on a lot of things?
It illustrates a lot of things. Yeah. Okay. Does that make sense to everybody? What the 2 conditions are and what the conclusion is? Or is there any question about the language? And to help you remember the language, what you want to do is to draw for yourself the standard example. Here's my F, here's my A, here's my B. I connect the 2 points, boom, and I find a tangent line that's parallel to it. This is the standard drawing that helps me remember the language, because I can now reconstruct from the slopes of the lines being defined. Does that make sense to everybody? Okay. Now, what happens if I don't meet the conditions?
You can't guarantee.
I can't guarantee it. Can I guarantee not? No, right? So it may be that this could still be true, or it might not be. What would it look like to not meet a condition? Well, we could break this one. If I have a function that is discontinuous somewhere, right? And if it's discontinuous, then I would have one of 3 types of discontinuity. What are they? What are my 3 types of discontinuity?
Removable, and infinite.
Exactly. That's right. So I might have one of those. Or, how would I break the second condition? If my function is not differentiable, give me 3 types of non-differentiability.
Short quarter, vertical tangent, and trestle.
That's it. Right. So if I have any of those things in the interior, or if I have any of these things at all, then I will fail to guarantee my conclusion right here. Okay. Now, let's do a quick example of using the mean value theorem, and then we will come back to our question. So here is an example. Let's do it like this. this is a very typical kind of a question. Here is the function f. Does it meet the conditions for the mean value theorem on 0 to 4? If so, find all values of c, and if not, explain. Think you got this? Everybody think they know how to do this? Yes, no? Go. Okay. Continuing on, the first thing that you should have done was to check the two conditions. First, we check continuity. Is f of x equals root x continuous on the entire interval 0 to 4? Yes. And all I have to do is to simply assert it, and if I really had to prove it and I was working with a hard grader, then I would use the definition of continuity to simply assert it. Okay? Is it differentiable on the open interval 0 to 4?
Yes.
So let's find f prime, and f prime of x is equal to 1 over 2 root x, and this has a value for every x in what domain? Greater than 0, that's right. So f prime exists. And I don't really care about x is bigger than 4, so I'm going to be specific, be specific. Yeah.
Did you have to show the equations for continuous and differentials?
Can you just say,
This is, oh, would you have to show this, or could you just assert it? I would probably give a little bit of evidence on the differentiability there, just to show that you know what you're talking about. When we come back to our question about G, then we'll talk about what our answer is. So, check on the continuity and the differentiability. So we need to find ourselves a value of C. And in particular, what I need is this right here. And that means that this is true, which means,
Wait, what? Wait, I thought it was just 1/2. Is it?
Oh, I see what you did. Yeah, okay.
remember the conclusion is that f of b minus f of a all over b minus a equals f prime of c for some c. And f prime of x is 1 over 2 root x, so f prime of c is 1 over 2 root c's.
So the answer is 1/2 equals 1 over 2.
We don't have an answer yet. We're looking for a c. We're not done until we get a c equals something. But it's pretty obvious what's the only c value that's going to make this work.
1/2. Half or 1. I mean.
C equals 1, right. And if you're not sure about that, flip both sides and get 2 root c is equal to 2. Square both sides, and c is 1. Yep. And there it is. How many of you successfully found c? Uh-oh, you all told me you were good with this.
I
What happened?
I forgot. I found out it's the premise.
Ah. What happened?
think I like 1/2.
Ah, okay. Very common student mistake. Watch this closely. Yura got 1/2 because she evaluated the average rate of change here, but this is not C. This is f prime of C. And so you must set f prime equal to of C equal and find that value of C. Okay? So on our graph here of y equals root x, the 1/2 that you found is the slope of that line, and I need to find the point where the tangent line also has a slope of 1/2, which is at c equals 1. So I set f prime equal to 1/2 my slope, and I find the value of c. Very common student mistake, now you know. How many of you guys found c equals 1/2? Okay, does it make sense why that doesn't work? Okay, any other questions about this before we return to our problem from last time? Okay, now find the average rate of change of f on the interval First thing, what is the first thing that I notice about this question that is different from parts A, B, and C? What's that? Yes, there's nothing about g of x. Instead, this question is about f of x. That's exactly right. So we're talking just about f, and I want to keep thinking in my mind, there is f, right here. Okay. Find the average rate of change of f on the interval. How do I draw something that will find the average rate of change for me? A line segment from the two endpoints, from -4, x equals -4, down to x equals -3. The average rate of change is that slope. And I know the function values already, the -3 and -1, and so I would say that the average rate of change, if you want a label for it, delta f over delta x is a very good idea. That gives me an average rate of change. Is equal to, now, y2 minus y1 over x2 minus x1. And I can stop there, or I can simplify it to get -2/7. Now they ask a really interesting question. There is no point for which f prime of c is equal to that average rate of change. Explain why this does not contradict the mean value theorem. Well, if my conclusion is false, what has to be true? Mean value theorem, what's that? Can't possibly apply, or the conclusion would be true.
I mean, like, part where it has to be different.
Okay, so the right way to say that is one of the conditions is false. If the conclusion is false, the conditions, one of them at least, has to be false. So now the question is which one? Oh, where do you see a point of non-differentiability? Bingo. So all that we need to say then is f prime of 0 does not exist. And now mean value theorem does not apply. And if we want to be really good communicators, be specific on the interval -4 to 3. Could the mean value theorem apply on some other intervals? Yes. Give me an interval for which the mean value theorem would apply. -4 to 0. Good. Give me another one.
0 to 3.
0 to 3. Give me another one. -4 to 0 already taken. Give me another one. Okay, reason it through a little bit. We said that the mean value theorem does not apply because my function fails to have a derivative at x equals 0. So reasoning backwards, my mean value theorem will apply as long as I have an interval that does, what's that? Got to have some good math learning here. He's on the cusp of a breakthrough, but he's a little stalled out. Europe, can you throw him a lifeline? Mean value theorem did not apply because f prime of 0 does not exist. So it will apply if I have an interval that does not
tail on those.
that does not contain 0. Give me an example of an interval that does not contain 0. -2 to -1.
Sure.
Any integral that, let's be specific, does not contain 0 in the interior. You have it. Okay. Don't forget your multiple choice. Christian, Earl, did I get homework from you?
I've got on.
Passers in? Okay, you get to say.